You ever just stop and wonder about the little bit of magic happening inside your phone? I mean, how do apps launch in a blink or games run so smoothly? It's so easy to think, oh, it's just the code someone wrote. But a huge part of that speed, it comes from an invisible process, a constant, quiet tidying up that's always happening behind the scenes. So today, let's pull back the curtain on that hidden world of refinement. Okay, let's try a little thought experiment. Imagine you're a robot, and these are your instructions for making tea. It all seems to make perfect sense at first, right? Pour the water, boil it, put the tea bag in the mug. But then you hit step 6. Pour boiled water from kettle into mug again. And you just have to stop and think, wait a second, the water is already in the mug. That step is completely pointless. It's just a total waste of time and energy. Now, it might seem like a silly example, but believe it or not, the code running on our devices is full of tiny, unnecessary little steps, just like that one. The good news is our computers are pretty smart. They're constantly running the same kind of common sense check in a process we call optimization. And the goal is super simple. Get the exact same job done, just with less wasted effort.
So how does a computer even start this whole tidying up process? Well, think about it. You can't really edit an entire book all at once. You gotta go paragraph by paragraph. And you know what? In the world of code, it's the exact same idea. We focus on one small, manageable chunk at a time.
This code paragraph has a technical name, of course. It's called a basic block. And you can think of it like a one-way street. Once the computer starts executing the code in that block, it has to drive straight through to the very end. There are no off-ramps, no sudden turns, just a direct path of instructions that are absolutely guaranteed to run one after the other. And here we go. This is what a basic block actually looks like in real code. Just a simple list of commands. And because there are no detours, our little automated tidy-up expert, which we call the compiler, can look at this entire block all at once. It gets this perfect bird's-eye view of the whole paragraph, and that is absolutely crucial for spotting ways to make it better.
But a good cleanup job isn't random. You don't just start throwing things out, right? Before the compiler deletes or rearranges a single thing, it needs a plan. It has to map out how all of these instructions are connected to each other. So its very first step is to sketch out a little blueprint.
Okay, now this blueprint has a pretty intimidating name, a Directed Acyclic Graph, or a DAG for short. But please don't let the name scare you off. It's really just a fancy way of saying flowchart. It's just a simple map that shows where all the data comes from and where it's all going, making it super obvious how every single step depends on all the others.
And building this blueprint is actually pretty straightforward. First, you just lay out your starting ingredients, your variables B, C, and D. Then, you add the actions, the plus and minus operations. You connect everything with arrows to show the flow. And here is the really cool part. Look at that fourth step. The map instantly shows you that we're calculating B plus C twice, for no good reason. The redundant work just jumps right off the page.
So, with this crystal clear blueprint in hand, the compiler can now roll up its sleeves and apply a few simple, common sense refinements to clean things up. The first and, let's be honest, most obvious trick is something we all do. If you've already figured something out, you don't do it again. Why do the same work twice? In programming, there's a name for this. It's called eliminating common subexpressions.
And this slide just shows it perfectly. In the before code, you can see we calculate B plus C, and we store it in a temporary spot called T1. Then, a little later, we do the exact same calculation all over again for T2. The after code is so much smarter. It calculates B plus C one time, and then when it needs that value again for T2, it just copies the answer it already has. Same result, half the work. Simple.
Okay, the next refinement is just as intuitive. If a piece of code is doing work that has absolutely no effect on the final outcome, well, you can just get rid of it. This is called dead code elimination.
I mean, think about it. If a line of code calculates some value, but then nothing else in the entire program ever looks at or uses that value, what was the point? It's just digital noise. It's wasted processing power. The compiler is smart enough to see this and can just snip, delete that useless instruction without changing the final result one bit.
And our final technique is all about being efficient. It's about swapping out a difficult, kind of slow operation for an easier, faster one that does the exact same thing. It's all about finding those clever little shortcuts.
A classic example of this is with multiplication. So on a really deep hardware level, multiplying two numbers can be more expensive. It just takes a little more time and energy than adding them.
So if the compiler sees some code that says x times 2, it will often replace it with a much cheaper alternative, x plus x. The answer is identical, but that tiny shortcut saves a fraction of a second.
Okay, so we've looked at the code paragraph, the blueprint, and the 3 main tidying up techniques. So now it's time to put it all together and see the big reveal, the before and after of our original code.
And here it is. On the left, you've got the code we started with, and on the right, you have the optimized version. It does the exact same thing, but just look at the difference. The repeated steps are gone, it's shorter, it's cleaner, and because it's doing way less work, it runs just that little bit faster. And here's the part that's really kind of mind-blowing. This isn't something that happens once in a while. This invisible tidying up is happening constantly. Millions, maybe billions of times a second, every single time you launch an app, play a game, or load a web page. All of these tiny refinements, they all add up, creating that seamless, fast experience we pretty much take for granted these days.
You know, when you really stop to think about it, it's a beautiful process. It's this perfect example of how countless small, thoughtful improvements, all totally hidden from view, work together to create these massive gains in performance. It's the quiet, invisible engine that just makes our digital world work.